Hello everyone, welcome to Noble Creative Tutorials. Today we have a new Stardust tutorial in our series and I will show you how to create 3D momentum balls simulation using Stardust and expressions in Adobe After Effects. Also make sure to watch expression tutorial series to be able to follow with me in this tutorial. So create your composition and let's get started. So after create your composition, create a new solid and let's rename this to Stardust and let's apply Stardust to it and then jump to Emitter and change emitting to ones and particles per second to 1 and 0 speed, and then we're going to add a model here and going to connect it to this particle, and there we're going to change life to 15 and shape to model and then jump to this model here, and we're going to change the model source to primitive, and we're going to create a sphere and let's give this sphere 10 and let's rename this to sphere, and we're going to add a null model here and connect it to this and connect it to this particle, and on model here we're going to choose primitive again and choose cylinder, and then let's maybe 80 for y, and here we have model property, so we want this to be on top, so just right there, and let's create a new camera and so we can see. So this is our shape here, and then what we want is add in here a transform node, and we want this to be rotating, and you would see it rotates according to this anchor point here, which we can change from here, but we're going to do something else. So we're going to create a new null and let's name this to N1, and then open this transform and let's make it 3D, and here we're going to zero out position, Y position, and maybe we're going to put it just right there, or just maybe 0 out and then make this model just 15, and put it just there. Okay, so here on our null now we are going to change the anchor point y value here, so our comp size is divided by 2, so we're going to put that to a negative value basically, so we have the anchor point here and the null shape here. So now we're going back to transform and we have here inherit motion, so we're going to select N1, this null, and basically when we rotate this on the Z, it's going to rotate according to this anchor point of the null. So this is what basically what we want, and let's put this just here, and we're going to duplicate this null 5 times, Control D. We're going to need it later, and let's organize them just like this, and we're going to back here to transform and connect it to this particle, and what we're going to do here is duplicating these 2 nodes, Control D. So now we have 5 particles and 5 transform nodes. So what we're going to do is connecting these to the same models here, so each particle node is connected to these models. All of them, they are going to be connected to the same emitter node, and then here we are going to assign here a different null. So for the second duplicate, we're going to choose N2, and for the third one, 3, and etc. So and now here, what we're going to do is just get here to these 1 and hit P for position, and we're going to move it right there, and you are going to make sure there's a contact here between these two spheres. And now we're going to reveal the P for the first one. Let's copy this value minus this so we know the distance. So this is the distance we're going to be adding here. So for this one, hit B, we're going to copy this value, paste it here, plus 201. So basically it's going to jump right there. So copy these to this one, plus the distance. Here something is missing. Yeah, so this is the 4. Need to be connected to this one as well. And then back to this null, copy this value, and here reveal position plus distance. So all they are there, and each one will be rotate according to its anchor point. And so now we want to start animating these. So what we're going to do is using expressions on these nulls. So here are for rotation. So the idea here is we want these to rotate on these axis, and this is we want it to be the maximum value, so 60 here, 60 degree, and then to stop right there. So we need to get to 0 to stop. So we have a range between 0 and 60. And for this one, which is the 5th, so R for rotation, we want that to be minus 60 and 0. So we have 2 range for that. So let's focus here in the first one. So we're going to use expression to achieve this, and make sure to watch expression tutorial series. I have explained how to use math expressions, which we are going to use in this tutorial here. So hold Alt and click on stopwatch, and then here we're going to create a new variable, frequency equal 1 for now, semicolon, and max angle. So our max angle is going to equal 60, semicolon, and decay equal 0.4, and semicolon, and you're going to create another variable. We're going to call it mForce equal. So basically this is the force that is going to rotate this pendulum here and give us the value that we need. Max angle times math period cos, up in parentheses, frequency times time times 2 times math period pi, and close parentheses, and we're going to multiply this by math exponential, so x, and up in parentheses minus decay, multiply that with time, and semicolon. So basically here we are going to get something like this. Let's preview this. So as you see, we're going to get these start animating, and then as time goes, as it's trying to approach 0 on the rotation until it gets stable. So here we have these animating on, like we have this graph here. So there's no limit for these. We want it to stop when these at 0 and not pass it. So we're going to use this expression called clam, and I explained it in the previous tutorial, so make sure to check it out. And so type here clam open parentheses m force comma 0 comma max angle. And what's this clam is doing? This is like, here we have the variable that we want to limit between 0 and max angle. So we have two values here. So basically the inverse, so whatever value the inverse give us, it's going to be between 0 and max angle. So now let's preview this. As you see, the pendulum here is animating between 0 and the maximum angle. And we're going to add another expression here, just in case we want to add more pendulum. So we're going to add these if statements here. If we want index equal these layer period index and open curly bracket, we want this to be our value here. So basically we're going to copy these and let's paste it here. And here we're going to change this to a negative value. So we're going to put there minus. So let's preview and see how this looks like. So as you see, these both are in sync. And of course, the ones in the middle, we want them to be animated as well. So here we are going to paste the same expression on the Z rotation. And except here, instead of 0, we're going to put minus max angle. So this is the range from minus max angle to max angle. And here we're going to change the max angle to just 10 and then copy this expression and paste it to the other two pendulum. So let's preview and see how this looks like. So as you see, we are now having our momentum balls simulations using the expression. And basically here, it's not necessarily to use the if statements in the index. We are going to get the same result. It is just adding if we want to have more conditions here to make it more even good looking animation or simulation. So now what we're going to do is make these looking a good 3D. So we are going to add here a material node and going to connect it to these nodes. So let's connect these to these two, and here on material I have here some textures here. So I have this HDR here and this texture of a scratch metal. I'm going to use them, so I'm going to add them here. And let's turn their visibility off. And here on material, first we're going to Stardust and render settings. Here we have environment. We are going to select our HDR map. So you start to see something here. And so let's add a new light, point light here. And maybe we're going to move it right there and jump to material. And here going to zero out color from particle, and we're going to assign here this texture. And as you see, we get it there. And here we have a roughness. We need to index these class and roughness here. And we're going to put these around maybe 3, so we start to see some reflections. And here we have reflections in metal, so depend how we want the look of that. So maybe we want it 100% metal. And here we have the ability to blur that, so maybe we go for this look. And we have here the environment amount, so maybe we leave it like that. And here we can make the environment visible. Let's zoom this a little bit, and we can actually here orient the environment as we want, so we get nice reflections. And we can mix the light here, so maybe we leave it like that. Here we're going to do some adjustment, so for these model, or maybe these, let's rename this to strain, and make the model X size to 0.1, so it's just like tiny string. We can see that anti-aliasing, so maybe if we go to extreme, it is going to a little bit fix it. So I'm just going to leave it at high. And here we can add ambient occlusion. Let's blur that. And we can add also a motion blur. And when you add motion blur, you see this problem here. To fix this, you just need to make sure you're working on 16 bits comp. So we fix that. And here we're going to add another model. So we want these to be connected to any particle here. And this one is going to be basically just the top bar for these momentum balls. So cube, going to put this 5 on the Y and 5 on the Z and 100 on X. And on the model properties here on origin Y, we can move that to the top, and we can assign the material to it as well, so it's have the same material. And we can basically add here the camera animation. And actually for the top bar that we added, we need to add its own particle node, so it's not affected by any transformation from transform node. And we're going to connect it to emitter and change the shape to model and give it 15 seconds and move the model where it needs to be. And make sure anything needs to be below the null object. And so now let's preview and see how this looks like. And so as you see, this is the momentum balls simulation using expressions and Stardust. And of course we can make the look of the materials look good than this, but you get the idea. And of course we can make a flat version just using After Effects shape layers, basically doing the same thing. So here the idea is just creating the shape here using the ellipse and rectangle, and here we don't need any null object, so basically just apply the expression to the rotation, so it's the same. Just here we have these master null, so we can just to move these momentum balls, all of it, all the elements. And so this is it, and this was the tutorial of today, and hope it was very useful for you guys. And if you have any questions, just comment and I will do my best to be responsive. And don't forget to like and subscribe to my channel, and stay tuned for more tutorials coming soon. Thank you for watching.